So what is measurement? Well, measurement is, if you think about it, it is the process of assigning numbers to some sort of construct, length, whatever it is, self-esteem, in a systematic way so that it reflects properties of those constructs. So it's assigning numbers. Measurement is assigning numbers so that we are reflecting properties of some underlying construct. So for example, intelligence, how do we measure that? Well, we got IQ tests, Wechsler and the Stanford Binet, for example. Weight, how do we measure that? How do we assign numbers to that? Well, usually with a scale. There's different systems for that. There's pounds, grams, etc. Here's a weird one though. So sex. So if we code males as 1 and females as 2 in a study, we have measured sex because we have assigned numbers to the construct of sex in a systematic way to reflect properties of sex, right? So it's a little weird that we do that in research, but we do that because the programs we use, like SPSS, the one we're going to use for this class, only really works with numbers. So we use numbers instead of word or text or characters to represent qualities like sex and also quantities like intelligence and weight and those sorts of things. So we call this numeric coding or categorical coding. It's the numbers we use to represent those categories. Some people use like 0 and 1 for sex, or it doesn't actually matter, which is something we're going to talk about. So measurement is assigning numbers to some construct in a systematic way that reflects that underlying construct. The scales of measurement, which is one of the, again, most important topics in this class, it's really foundational, it's like dribbling in basketball, is how a construct is measured. So how did you go about assigning those numbers? What scale? And there's the 4 that are usually talked about. So there's nominal, ordinal, interval, and ratio. And we're going to talk about each of these in our own slide or two. So I remember these back in the day because of film noir. No One Is Ready, or film noir, nominal, ordinal, interval, ratio. They get more complex as you go from 1 to 4 mathematically. Or if you're the 80s, they had Drakkar Noir, was some like clone that like just everyone wore. So that's another way to memorize the different scales. So they are presented here in sophistication from least nominal to most ratio. So the nominal scale of measurement is our first one. And something is measured in a nominal scale of measurement if the values are just categories or qualities. Okay, they're not quantitative. So like sex, for example, where we're saying males are 1 and females are 2. We're just saying those numbers don't, like, you can't do math with them, right? You can't get mean sex or something like that. You just sort of like take them as they as labels for purposes of research. You can't even order them meaningfully, actually. So not only can you not take a mean, you can't even put them in sort of meaningful order. All you can say is 1s are in that group, 2s are in that group. So one way to remember this is that the root of nominal is nom, which is name in Latin. They're just names for things. So in real life, there's basketball jersey numbers, right? So those are a nominal scale of measurement. Like if you sum the jersey numbers for some team and compare them to the sum of some other team, you have successfully done totally meaningless math, right? Math for no reason. So they don't have meaning. Nominal variables don't have quantitative properties. It doesn't have meaning. Channels on your TV, right? It's just channel 40 is channel 40, channel 13 is channel 13, 40 isn't somehow better, right? They don't have the numbers are just names for things, right? Channel 13. In research, we have ethnicity as an example. So you might use 1 to stand for Black, African American, 2 for Asian, 3 for white, etc. They're just numbers that represent the categories they're in. You can't do any sort of math with them. Phone numbers are like this. We talked about sex already. So the numbers represent qualities or categories. You can't compute meaningful means or sums or anything like that. And we use these a lot because we do study things that are categorical in nature, qualitative in our research. So gonna have to get used to nominal variables where we don't actually type in, male or female. We use one or two, something like that. So a little more complicated mathematically is the ordinal scale of measurement. Um, it kind of looks like order, right? When you look at the name ordinal, and indeed, that's it. You can order these ones. So they're still not super mathy, but you can order them. So the values can be ranked or ordered, but they're still not really otherwise quantitative. They don't have what we call magnitude. So you can say, 1 came before 2, and 2 came before 5, and that's about as good as things get with ordinal scales of measurement. So what they lack is magnitude or equal intervals. That is, a 1 unit change in an ordinal scale does not necessarily mean the same amount of the underlying construct, right? So we're going to have an example of this in a sec. Finishing places in a horse race, right? So you got first, second, and third, right? You know who came in first, second, and third, and that's about it. You don't know anything about the underlying times. It could be that, first and second were really close to each other, and then third was, 6 or 8 seconds later, right? All you know is the order of them. You don't actually know anything about the underlying sort of magnitude of differences between them. And that's what we mean when we say it lacks magnitude or equal intervals. A 1 unit does not necessarily change, does not necessarily mean the same amount of the underlying construct. Yep, there we go. So how about if I asked you to rank your top 10 favorite types of food, right? And you might say, well, Mexican, well, I might say actually, Indian, Chinese, but like I really like Mexican food. I'm from California. It's my jam. Um, I love Mexican food. And then, second favorite is Indian, but it's down there from Mexican food. I get to eat Mexican food every day and probably do to the chagrin of my wife. But I like Indian and Chinese about the same. And so again, I could order them for you, but it doesn't necessarily, 1 unit change here is not the same amount of liking, I guess. Okay. So if we were to order basketball jerseys from low to high, does that have some sort of meaning in any way? So can you say, player 24 is somehow better or more skilled than player 30? No, right? You can't. You can't do math with these really either. Okay. So even if you order a nominal variable, it's still a nominal variable. Okay. Can't magically start doing math with it. So for ordinal scales of measurement, the numbers can be ordered, but sums and means do not meaningfully represent the underlying construct. So these are the two most basic ones. It's about to get crazy. The third one is the interval scale of measurement. And this is quantitative or continuous. That is, we assume with interval scales, the values are measures of some underlying continuous construct. So interval scales of measurement have magnitude, that is, they have equal intervals. So a 1 unit change anywhere is the same amount of the underlying construct. So the differences are meaningful, is what that means. What they lack is a true 0 point. That is, 0, if it even exists at all, is arbitrary, right? It's set at some level that doesn't necessarily mean 0 of the underlying construct. And so we need some examples. Obviously, temperature is on a interval scale of measurement. So for Celsius and Fahrenheit, a 1 unit degree change is a 1 unit degree change. It's the same amount of whatever the heck it is, like energy calories required to heat 1 gram of water 1 degree. It's something like that, right? But what is 0 on Fahrenheit and Celsius? Does that mean the complete absence of heat? No, right? So they are not the next level, which is going to be a ratio. They do not have a true 0 point, but they do have meaning in terms of quantity and magnitude. So we know, for example, that 70 degrees is 10 degrees above 60 degrees. That is 10 1-unit changes. And we know that the difference between, say, 90 and 95 degrees is the same amount of heat, the underlying construct, that is, as between 50 and 55, right? So 1 unit is 1 unit is 1 unit is the way to think of these. But 0 degrees does not mean the complete absence of heat. It's when like water freezes at like whatever sea level or something like that, or salt water. I forget exactly what it is, but it doesn't mean the complete absence of heat. Kelvin, for those who are super nerdy, does indeed have a true 0, where 0 on Kelvin means the complete absence of all heat, right? So we don't really achieve that on Earth, I think. So intelligence, that is IQ, as we usually measure it with intelligence scales, is a interval scale of measurement. You know, a unit's a unit is a unit, but it doesn't have a true 0 point. So the thing about interval scales of measurement is they're very common in the work that we do, psychology. The numbers not only can be ordered, but you can actually do sums and take means, and they meaningfully represent the underlying construct or variable. So nominal, ordinal, and interval. And the final one, oh no, okay, so more on interval. Oh gosh, yes, this note, psychological measures. So there's a lot of things that we deal with that are psychological measures. Psychological measures, IQ, self-esteem, anything psychological like that. There's just sort of this gentle person's agreement that they individually lie somewhere between ordinal and interval. Okay, so you can order them for sure. Higher scores, more of the thing. But are they truly equal interval? So frequently we use these Likert scales where it's like 1 to 5, how much you agree with the statement, or 1 to 7. Those are 5 and 7 point Likert scales. The agreement sort of is that if you use just one of those, it's probably ordinal. So there's a difference between a 3 and a 4, really the same amount of underlying construct as between 5 and 6. I'd say probably not, right? So people tend to answer these things in ways where they use a response set, so they either go to an extreme or the problem is ordinal stats are like old school, and so there's sort of this agreement that while individual Likert items are closer to ordinal than interval, interval level data is approximated when responses are summed across multiple ordinal Likert items, measuring that construct. This is basically why there's no like self-esteem questionnaire that's just one question. What's your self-esteem? 1 to 7, right? We know those things are not very, first of all, they're not reliable. They're also not valid. We got lectures on that topic coming up. But they're also probably ordinal, not interval. And you need at least interval to do most of the fancy stats we do in this class. So this is why questionnaires are more than one item. There's a gentle person's agreement that when you sum across multiple Likert items, you get something that's closer to interval. That's the agreement. So the rule in this class is just assume that any psychological measure, whether it's the Big Five Neo-PI, it's IQ, self-esteem, any of these crazy constructs we measure, that it's interval, okay? Because we call that scale in SPSS. But just assume, you know, if it's a psych measure, actually don't even think, just say, yeah, interval, okay? And you'll be very successful in the course. All right, so now finally, we've got the ratio scale of measurement. This is one of those ones where the name has meaning. You can do ratios with ratio variables, hence the name. So they are also quantitative and continuous, so the values are measuring some underlying construct. These have magnitude, that is the interval property of equal interval, A 1 unit change does mean the same change in the underlying construct. So you can do differences with things measured on interval, but it has an absolute 0 point or a true 0 point. 0 means none of the underlying construct on a ratio scale. So you can calculate ratios. So this beer is 50% larger than that one, for example. You can do, that's a ratio. You can do ratios with ratio scaled variables. So if 0, when you're going through and trying to figure out scale of measurement, if 0 means none of the quantity, okay, even if it doesn't make logical sense, like someone having 0 weight or 0 years of age, that sort of thing. So it doesn't have to be real. It doesn't have to be a value that someone could actually have. But if 0 means none of that underlying construct, you've got a ratio scale of measurement. So some examples. Height and weight are sort of obvious ones. 0 inches, grams is the complete absence of weight. A gram is a gram is a gram. Can someone weigh 0 inches or 0 grams? No. You can't, but an inch is an inch and a gram is a gram, right? So you've got those equal intervals. And 0 means none. So it is a ratio scale. It's not arbitrarily set, like with interval, for example. So scores on a midterm exam. Is that a ratio? Well, in one sense it is. So 0 means you don't get any points, right? But what we're trying to measure on an exam is your underlying knowledge of the course material. So does 0 mean you have no information about the course material? Well, if you're thinking about it as points, 0 would be ratio. If you're thinking about knowledge, it would be interval. Okay. So here's the good news. SPSS treats interval and ratio the same. They just call it scale. So SPSS only has nominal, ordinal, scale. That's all it has for scales of measurement. And if you can establish that a variable is at least interval, so it's one of these psych measures, that's good enough for this course. I don't bother you having to figure out, is it interval or is it ratio? Is 0 true, right? Because it turns out it doesn't matter. So why waste your time with that? So interval / ratio is good enough for this course. So we also broadly classify research variables into these two categories, qualitative and quantitative. So I got to hit it at some point. Qualitative variables, we also call them categorical. Sometimes we call them discrete variables. The values for the variables represent groups or categories. So your nominal variables, for example, all fall under qualitative variables. So the values are just what group they're in or what category they are, right? So all nominal variables are qualitative, and generally ordinal ones are as well. So eye color, sex, handedness, state that you came from, or who's likely to pay for your med services. These are all variables that we would say are qualitative. Now, quantitative variables assume, or another word for it is continuous. They assume that the values represent properties that follow along some sort of continuum. So whatever it is you're assigning numbers to measure, there is an underlying continuum of numbers that you could be assigning. Okay, so all ratio and interval variables are quantitative, so you can do fancy math with them. So IQ, interval, self-esteem, interval, likelihood of having an eating disorder, ratio, cost of treatment, ratio. We can just call them IR/scale. These are all variables that we would say are quantitative. So it's just another way of I'll use these terms, so I have to introduce them at some point in the course. There's also qualitative and quantitative variables. So to determine the scale of measurement of a variable, you have to know how it was measured in a study. And it matters and it's important. And the same variable could be measured on different scales of measurement in different studies, or even in the same study, like if you really wanted to drive people crazy. So for example, income. What scale of measurement below is income measured on? And so you can't answer without knowing how they ask the questions, right? Do you have an income? Yes, no. what 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 scale of measurement is this? Well, if someone's a yes, all you know is they're in the category of people who have an income, and the no's aren't, right? So this is nominal. This is just you either have one or not. You are a group, okay? So this is income measured on a nominal scale. How about what's your SES? Poor, middle class, rich. Well, so whatever numbers they're used, 1, 2, 3, right? Or, 0, 1, 2, or 99, 98, or 98, 99, and 100, you can order them, right? And you know that basically a higher category, they make more. It's not equal in any way, or you can't do fancy math with it. You know that someone who's rich makes more money than someone who's poor, right? And some middle class than someone who's poor, etc. So this is an ordinal scale of measurement. Okay, those were the easy ones. You ready? How about this? So you see this from time to time on questionnaires where they just have these categories. You either make less than $10,000, 10,000 to 39,999, or greater than or equal to $40,000. These are the three categories that you fall into. And again, in SPSS, we'd use like 1, 2, 3 or 0, 1, 2 or some sort of numeric coding scheme. So let's think about this. First of all, everything's at least nominal. So can we get order out of this? Do you know if they're in one of the other categories that they made more money than less than 10,000? Yes. So we have order here. So do we have equal intervals here? Is the amount of underlying income the same between categories? And the answer is negative. You do not have equal intervals. So while that 10,000 to 39 is, $40,000, if you're in that upper category, you could be anywhere from 40,000 to a multimillionaire, right? So you can order folks, but you could say like the people in the greater than equal to 40,000 make more than those in the other two categories, and that's about it. Can't do fancy math, can't average, that sort of thing. So this is also ordinal. You do not have equal intervals. You also don't have a true zero the way they measured it here. So how about this? Do you earn $1 to 1,000, 1,001 to 2,000, 2,001 to 3,000, etc.? What scale of measurement would this be? Well, we have order, right? If you're in a higher category, you make more money than someone in a lower category. The categories do have equal intervals, right? Each one is $1,000, like assuming it just keeps going up. And it's a massive list of possible incomes because it's only by 1,000. What's zero on here? Yeah, there isn't even a zero on here, right? So scale of measurements on this one, we have order, we have equal intervals of 1,000. What we lack is a true 0 point. That's the hallmark of an interval scale. So we have equal intervals, no absolute zero. So how do you measure ratio income? You just ask like this, right? How much money do you make annually? Somebody can put zero in there, and if they put zero in there, they make no money. And then if they put a non-zero number, a dollar's a dollar's a dollar, right? So it's the same amount of income. So this would be the way they measure it, ratio. So why don't they ask it this way? Because people don't answer. That's why. So having done surveys in the past, number one question people lie on is their income. And so that's why they do the groupings of things so that people actually give responses. So in this course, you do not need to differentiate interval versus ratio. It's all called scale in SPSS, and it's called I/R on the assignments. So final slide is thing number 2 that is so important. I have to kick it like a dead horse and just go make you do tons and tons of problems trying to get this straight in your head. What are the scales of measurement? So it's going to turn out that not only do you need to know what's a variable, what's the interval, excuse me, what's the independent variable and what's the dependent variable, but what stat you use is going to depend in the future on what the scale of measurement was. And so you have to get good with scales of measurement to be successful, not only, again, in this course, but with your dissertation. It's how you'll know what stat to use and also in the future. So your job on the scales of measurement assignment, which is also out there and also in 2 parts, but it's about half as long as the IVDV one, is to tell me what's the scale of measurement. So this is an assignment that's actually on Canvas. So let's do it. Your choices are nominal, ordinal, or interval/ratio. So you have 3 choices. For number 1, position in the company, supervisor, vice president, president. And you can see there's some numbers there representing those categories apparently. So what scale of measurement is this? Well, everything's always nominal, right? So can we get to ordinal? So if you are higher on here, are you higher position in the company than lower? You are, right? So we've got order. This is at least ordinal. Do we have equal differences between the categories? So the difference between supervisor and vice president is the same amount of underlying position as between vice president and president. No. So we're done. This is an ordinal scale of measurement. How many miles do you live from the university? Underscore miles, and they can write whatever they want in there. So can they live at the university, and could they put 0 in there? Who knows? Probably not, right? Some people do live on campus, for example, of other universities. So 0 would mean 0 miles. It would be none of the underlying miles, right? Distance in that unit of measure. And so is a mile is a mile is a mile? Sure is. We've got something that's ratio actually. So we're just going to call it interval/ratio. Please indicate your income level. Oh God, another one of these. 0. These all look like they're 10,000, right? So these are all 10,000 wide. So we have equal intervals. We have order. So this is at least interval. And again, that's all you need to know because I/R is good enough. I/R. Turns out it's actually interval because 0 on here. If you're in that first category, you could be anywhere from 0 to 9,999. So this does not have a true 0 point, but who cares? It's interval/ratio. Please indicate all of the following psychology classes you have completed. All right, so they're just circling classes, and I guess we're talking not about the quantity of classes they pick here, just these are the ones I chose, right? Or these are the ones I took. So if someone selects 114 versus 103, does that mean they somehow took more classes in psych or harder or something? No, not really. So these are just numbers that represent courses, just like the course you're in right now. The number just represents category, being a member of a category, and so this is a nominal variable. And finally, like it looks like one of the rules here is if it's a blank, it might be interval or ratio, but not always, right? Because I could ask you for your race with a blank, and that would not be a interval/ratio variable. So let's see what we got here. Please tell us your age, blank years. All right, what do you think? Well, we have something here. So can someone be 0 years old? Like I guess before they're 1, right? They're 0 years, but we're measuring something in years here. So 0 would mean 0 years. So and a year is a year is a year, same amount of time. I'm pretending there isn't leap years. And so we've got something that's at least interval or ratio, technically ratio. So that is your assignment. Again, it's in 2 parts. So by Wednesday this week, get the first half of it done. That's part 1. Make sure you participate in the discussions if you're having trouble with this. I know both these concepts aren't easy for students. This is why I have you repeat it so much so you can get it right. I have an office hour on Wednesday. We can talk about things. You can talk with other students online. And you got to get this down. Give the first half a shot, and then the second half is due by the end of the week. So that's it.